Well, I think we're up. We're working. You can see me, I can't see you. But this week, I'm going to do a much better job of trying to chat with you. So let's start there really quickly. If anybody's watching, let me know, can you hear it? You can just type it into the chat. Can you see my face? What do I look like? Am I green on your screen? If I'm green on your screen, there's not a lot I can do about that. You should probably invest in a better monitor. But if I'm sounding good and looking as good as I can, then I think we're gonna get started. So what do y'all think? Do I look good? Do I sound good? Anything? There are people, presumably, that I love and that love me watching the stream today. And unlike your friends who will let you walk around all day with your zipper down and not tell you anything, the people that you love will usually let you know. Now, they're gonna take you aside and do it in front of your friends, especially if it's your mom, and probably embarrass you even more, but they'll let you know. So let me know if it sounds good or sounds bad, or if there's a problem, or if you have a question, or you just want to chat. I mean, that's what this is all about. This is about trying to connect while we're all stuck at home. I know that I have been going crazy. We bought a inflatable hot tub, which is pretty redneck, but also pretty awesome. The kids are out there swimming in it right now and having a lot of fun while I'm in here doing nerdy stuff. So welcome to the OscopeWizard. I went on a run this morning to try to get ready for the show, to get the stress out, because I was a little nervous. I always get a little nervous before I perform. And when I was out, I saw a fox, and it was kind of a magical moment because I was walking along this path through the woods, and as I was walking down the path, the fox came towards me, and we probably got, I don't know, 10 feet apart, and it wandered off into the woods. And yeah, it was magical. And guess what the fox said? It said, so I have the answer. That's what the fox says. Today, what are we going to do? We're going to try to do some experiments with an oscilloscope. I have my handy dandy RTO oscilloscope. I think, let's see, here's the picture of it. Everybody should be able to see it. I have it plugged in. We're going to be using that guy to do some experiments with my Raspberry Pi that I have plugged in. And last time we started by looking at the USB link between this controller and my Raspberry Pi using this kind of fancy adapter board, it's called a compliance fixture, but we were making some tests. So we were doing electrical engineering test, which is what I do for a living, and hopefully you're interested in that, or at least interested in just hanging out and chatting. And I do see a post that says I sound great. Thanks, babe. I appreciate it. Let's talk about what I want to show. So I'm going to show some slides because, you know, I've been doing this for 15 years and I do lunch and learns all the time, and I haven't done a lunch and learn in months, well, weeks. And it feels like years. When you do something every day and you don't do it for a week, it feels like you haven't done it for a year. I mean, as an example, we do school every day. The kids go to school, and if they stay home for 3 days in a row, it feels like it's been 19 decades. And we are on week two of staying at home, but this is actually spring break, so there's no school this week, but they're still at home. It's getting a little small in the house, but I digress. I digress a lot. That is a big part of, in fact, my demonstration. Mostly it is digression. let's talk about what I would like to accomplish today. I want to probe the USB controller, and I have the controller here. Whoa, right here. Does anybody recognize that controller? Anybody? If you do recognize it, you can type it into chat and let me know which controller it is. I've had it a long time. When my son saw that controller, he said, "Dad, we still have one of those?" And in my mind, that is a new controller. I mean, that is a pretty new game system. Let me know what game system it is. If you know, you can just hit me up in the chat. Next, after we probe the controller, which we've already actually done, I want to press the D-pad and buttons and see if we can determine what that looks like on the actual USB link. And then I want to figure out the commands that this controller is sending to my Raspberry Pi in order to make the character on the screen move. So let me go over to the setup. Here is the Raspberry Pi. Does anybody know the video game that is playing on the Raspberry Pi by any chance? Anybody? It's literally right there. You can probably see it. It is, nobody's gonna say, that's fine. It's a very quiet audience. I'm very used to a quiet audience. In fact, most Lunch and Learns have quite quiet audiences. I have had audiences that literally fell asleep, which was a little sad, probably an indication that I needed to pick up my game. That's nothing with them, it's more it's a me problem. But that is The Legend of Zelda Link to the Past, which is maybe my favorite game of all time. That's debatable. We could probably talk about that in a future episode about what is your favorite game of all time. And I'm using an Xbox 360 controller to actually control the thing. Let's see if I can make it control here. Control. But that's my controller. And what I want to do is figure out how to probe these signals that are on my board and get them into my oscilloscope and then check them. So that's what we actually did in the first episode. So let's get back to where we were. So when we did last episode, I talked about some basic good practices. So I would call those pro tips. One pro tip that you want to always do when you sit down in front of an instrument is preset it. So right now I sit in front of this instrument. I don't know what the last guy did, or girl. It was actually a guy, though, because it was me. So that's neither here nor there. I can't remember what I was doing last, and I want to make sure that I don't have a weird setting on in the background. So first steps first is preset. Let's preset. So now we'll preset. And then we could make it kind of easy. I actually stored a setup from our testing last time on last week, and I can just recall that to make it a lot easier. So there is the setup that I stored, and on this particular oscilloscope, the RTO oscilloscope, you can just look through your old setups, and if you see the picture that you remember, you can load the setup that goes along with that picture. So I remember that we were doing this because this is called an eye diagram because of the shape. It's kind of shaped a little bit like an eye, not like my eye. My eye would be a little bit, that would be a bad eye diagram, but this is a nice big open eye, so this is a huge, beautiful eye. I can load that. Another thing that's a little weird is the signal that was on that picture had pink, and the reason it's pink is because I added the pink collar to my probe because I really like the color pink, and I want to make sure that the signal color is pink. So I did it last time, but a lot of you guys weren't on last time, so this is new to you. So let me show you how you can change the colors on a signal. You can go to display, colors, and I will choose pink. And now it matches. Now I have a pink signal to match my pink collar on my probe, and the front of the oscilloscope, if you look, can you see? The front of the oscilloscope color over here actually turned pink. So let me move this camera over so I can get a little bit closer to what I'm working on. And we can still talk because I definitely want to keep talking. Oh my gosh, I forgot to set my timer, guys. I think my timer is, I think I've been talking about 5 or 6 minutes. So let's say, let me set my timer for 15 minutes because I don't want to go too long. So let's hit start. And that will remind me to stop talking, which is that when it comes to a sales guy, getting them to start talking is super easy. Getting them to stop talking, that's a little bit more difficult. So that's why I'm going to have the timer there. I have the signal plugged in. So now we have the setup that we had last time when we're making a measurement. But this time I'm not so excited about the measurements. I don't really care about the measurements. So let me delete the measurements. I'm much more curious about the commands. So let me change my trigger mode and my slope, and let's zoom out a little bit. So now if I zoom out, move this over, this is what a USB command looks like. And if I press a button, it gets longer because that's the actual command. So right now, while I'm not pressing any buttons, I'm not pressing any buttons on my controller right here. And I still see commands on the screen. So this is just the USB link itself saying, hey, I'm alive, I'm still here, watch me, don't forget. But when I press the button and it gets longer, so you can see that command getting longer over here, that is when data is actually being sent from the controller to the Raspberry Pi. So I'm sending it along this link. Let's see, my link right here. Do you hear that? I'm playing Zelda, I'm saying link. Feels like this might be in a moment. We might be in a moment right here, folks. But it sends this data, this key press, along this link to go into the Raspberry Pi to tell Link to move up, move down, maybe throw your magic lamp, shoot an arrow, throw the boomerang, whatever you're gonna do. But they correspond, so these different buttons are gonna send different data packets, and we're gonna look at that. The other thing that I need to be mindful of is that USB is not just one signal, it is actually two signals in the universal serial bus. It is called a differential signal, and that means that there is a positive side of the signal and a negative side of the signal. You see this a lot with USB is a big one. You see it with PCI Express, which is a big one, which is going to be your graphics card. If you don't know what PCI Express is, not a big deal. Another really popular differential serial standard would be Ethernet, which we are all struggling with right now, I suspect, in your house, because you were not thinking that you're going to be stuck at home for months. And now your home internet is those differential twisted pairs of Ethernet lines are screaming. But again, I digress. I feel like most of the time I am digressed. I'll plug in channel 2 over into the negative side. Oh my gosh, I need tinier fingers. I usually have a couple of producers to help me with that, but not today. Okay, so now I have channel 2. And I'm going to make it a little bit easier to look at channel 2. I'm going to drag it down to the bottom down here, and I'm going to scale it so that it fits on the screen. It's really important when you're using, when you're using anything electronic, it's really important to scale the signal so it doesn't clip. It's true for oscilloscopes. It's true for volume control. So if you turn the volume too high, it starts to clip That can be the circuitry and the electronics are a little, like the voltage has gotten too big for it to handle. The clipping could also literally be your analog inputs, your ears telling you to turn the volume down. So we don't want to clip because it causes bad things in general, except when it comes to electric guitars. And in that case, clipping's awesome. So let me take a single capture. I think one of the things that I can do over here is add a single button, and I can also hit run stop so that you guys can follow along at home and see the buttons that I'm pressing. So I'll hit single, and then I want to zoom in. So I'm going to zoom in a little bit and let's see this USB signal. This is a zoomed in section of this USB signal. So let's try to figure out what I'm looking at. Before I was looking at the height of the signal, I was looking at the voltage of the signal, and I was also looking at the width of the signal or the timing of the signal, and that was my eye diagram. Now I am looking at it all in a line. So this would actually be the ones and zeros. So this is how the USB signal is being transmitted. You can see right here it goes up, it goes from 0 to 1, and then it stays 1 for 1 bit. So that is a 1, and then it goes down, and it looks like it stays down for 2 bits. So that is a 1, 0, 0, and then this looks like it is 3 or 4 bits, I don't know. It's tough to tell without a clock, and that is one of the tricks. So let's say 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, and then a whole bunch of zeros. So that is how data is actually transmitted when you talk about digital data and you talk about ones and zeros, and that's something that people say all the time. Oh, that's digital and it's just a bunch of ones and zeros. These are the actual ones and zeros that they are talking about. And you can see where it would be a little bit tedious. So if I did another single here and I had to count just this one section, and you'll notice I'm zoomed in on this one section. Let me hide channel 2. So I'm going to hide channel 2 for a second. So now I'm zoomed in on this one section, and again I could count the ones and zeros and write the data down. So I could say 1 0 0 1 1 1 1 0 0 0 0 1 0 1 0 0 0 0 1 0 1 1 0 0 0 0 0. That would take a long time, and in fact, if that is how we had to do serial data on an oscilloscope, it would be a literal nightmare. You would spend your entire time counting ones and zeros. And I remember when I first started right out of college at my first job, our oscilloscope did not have any serial decoders. It just captured data like this, and we had to count ones and zeros, and it took a large portion of our time just counting ones and zeros. And I'm talking about an engineering degree that I just spent 5 years getting. Thanks, Mom and Dad. That extra year was real helpful. I just spent 5 long years getting an engineering degree, and my first job, I was counting ones and zeros. It felt like a lot of work to do a very mundane task. But a lot of engineering is actually pretty mundane tasks done perfectly, so that they can be repeated over and over and over again. How are we doing in chat? Any questions so far? Sounding good? Looking good? All right, we're getting overwhelmed, bombarded with questions and comments. So I don't want to do ones and zeros all the time. I would like the scope to do a little work. I mean, I did just spend some money and get this really fancy oscilloscope. So let's see what the scope can do. If I go over to, oh man, analysis, serial bus, or on the front of the scope, there's a button that says protocol, and I usually press the button that says protocol when I do a demo, and it's really funny when you do something the same way over and over and over again, and you have to make one tiny change, it can really throw you for a loop. But this is not going to defeat me today. From protocol, I can select USB 2.0. I can tell the oscilloscope that I am going full speed. We established all that in the last episode. You don't have to watch that. The sound was terrible. I'll probably go back and just re-record a quick video going over the things that I did in the last episode to bring you back up to speed. And then I will hit decode. Now, I can see, magically, I am the wizard. I mean, of course there's magic. In fact, so much magic. Let me take a quick break, sip of tea. What? I think I might hear something. Let me see.
5 minutes left!
Oh, guys, I think that we're running out of time, so let me get to the actual decoding here. So I have a decoder going right now, and it is decoding. I'm going to dock it at the bottom of the screen so that I can see my signals at the top and I can see my decoding at the bottom. And then I want to actually, so if I just hit run now, move this over, zoom out a little bit more so that I can see, oh, I just want to see one burst. Now I'm going to take my controller right here. Let's see, you can probably see it better over in this camera. And I'm going to press a button. And you'll notice every time I press the button, I do get a little bit of something right there. Now I have ways that I could grab that, but the easiest way to grab that is using a trigger. So oscilloscopes have a very powerful concept called a trigger. And the trigger's entire job in life is to tell you exactly when something happened. That's all its job is in life. It is sort of like a tattletale, but not bad. So a good tattletale, maybe? That probably is where we're at. So I'm going to set up my trigger to, instead of just triggering on my channel, I want to trigger on my serial bus. And I want to trigger when I get a data packet. So I'm going to trigger on data 0. There you go. Now every time I press my button, let's move this into the center. Every time I press my control pad, you can see that I'm actually setting up a trigger, which I think is really, really cool. And if we zoom in right here, let's see if I can zoom in right here, I can actually see the bytes. So you remember last time I was having to count bytes, like 1010001000. Now I can use my zoom window. Let me turn this so you can still see me. And I can move through the data and I can see each byte decoded. So if you'll see that says byte 5, 13 hex. I won't make you learn how to do hex today. That might be a lesson in the future. I'll take you through my entire 5-year engineering degree, and by the end of this whole experiment, you will be junior electrical engineer OscopeWizards, and you can join me and maybe even do some demos for me. I would love to see somebody try that. But we're looking through the data, and I can see that I have 0 hex, byte 7, byte 8, which is really cool. So now I'm making the oscilloscope, do some work for me. It's not just sitting around doing nothing. Let's get some more data on there. Now, one thing that I notice, and you may have noticed, is this data. Let's see if this data changes when I hit different buttons. So I want to figure out what data these different buttons are sending to my video game over here. Because each button, the video game needs to be able to determine the difference between each button. Otherwise, every button would do the same thing. They'd all just shoot, or they'd all just jump, or they'd all just whatever. So if I hit down, I can see that I'm getting 0, 1, 0, F. Oh, it looks like all the buttons are sending the same data. So now sometimes I'm getting the button down, so that's the button down. And you can see I'm holding the button down, and then when I release the button, there's a different command for button up, button down, button up, button down, button up. Let's press a different button. Let's press the A button, button down, button up, button down, button up, button down, button up. Am I getting this? Am I getting different data? No, it looks like it's the same or very similar data. Oh, now it's slightly different because I pressed my analog stick, which does different data. But there are actually different data types sent in USB. So I'm triggering on the data 0 packet descriptor, but there's a whole nother packet descriptor that will transmit data as well. And it looks like I am out of time, guys. I guess we'll have to save our setup for next time. So let me go to save the setup. Let's stop the timer. The timer is, we're good. Thanks, timer. I appreciate it. You did a good job. Let's save where we are. So we'll go to save. Save sets. Just save it. And I'm gonna be a good citizen, and I'm gonna preset the oscilloscope before I turn it off. But thank you so much for spending 20 minutes with the OscopeWizard today. I'll be back on later this week, so if you didn't catch it today, please join me again and we'll continue going through some basic electrical engineering and testing of all kinds of different things. I have big ideas. We're going to do Raspberry Pis. I have a record player we could check out, a bunch of audio stuff that we could do. I've been really curious to see how auto-tune works in the frequency domain, so we might do that because I really loved auto-tune music. And I am going to hang around in the chat in case you have any questions or comments that you want to drop into the chat. Otherwise, it's been great, guys. I appreciate it. Thanks for watching. Please let a nerd know. Tell them to like, comment, or subscribe. I think actually you're supposed to like, comment, and subscribe. I would take any one of those three, though. Thanks, guys. Later. Bye.